Okay, what do we have today? Brake disc. Box. Oh, brake pads. And then little hydro reservoir, master cylinder, and slave cylinder. Okay, so is that a pull or is that a push? It must be a pull. Let's make it work. I must admit, I thought I'd ordered a cable one, not a hydraulic one. But hydraulic is probably better, what I'm after. As long as I think that hose is going to, yeah, that hose is going to be long enough. Yeah. Okay. I don't have the little lever I was going to use, but that's okay. I'll just make something else. I think it's going to work fine. I think it'll work fine. So, strange, we've got a spare brake pad. Oh, this came with brake pads in it. So I've got brake pads and a spare set of brake pads. Tell you what, I've got to be doing a lot of lathing if I wear these brake pads out. But okay, I guess. Okay, so let's see how this is going to work. I have no idea exactly how I'm going to do this yet. I've got a rough idea that I'm going to mount this on the motor pulley, make some sort of foot bar that will kill the electric to the motor, and then apply the brakes to it. I think that's how I'm going to do it. So it's all going to be a bit of an adventure. Okay, great. So the motor's down here. So the best thing I'm going to have to do is move the grinders, move this bench. I'm probably going to move the whole bench that way a bit because it doesn't give me a lot of room to get to the gears on the end of the lathe. When I did all this, I wasn't really forward planning enough to give myself enough room. So I think I'm going to move the bench that way a little bit anyway. But I need to take all this off and just find out if I can attach all that to the pulley of the motor and how I'm going to do that. Okay, so I was thinking of coming off the motor pulley, but the motor pulley is a bit small and without making an adapter plate and things. So then I thought I'd come onto the main drive pulley on the gearbox. So I've just undone the Allen on the end. Let's just try and get it off. I want to pull on the edge of the pulley. These cast iron pulleys, you can snap that rim off as easy as blink. So I always try and push on the main centre. The amount of times I've seen someone get a puller on one of these cast iron pulleys and they start going and they give it a little tap in the middle and they snap the rim off or snap a lump out of the rim. These cast iron pulleys are very delicate. So always, if you're going to try and do it, you've got to be pulling or pushing on the main boss. Some of them have got screw holes in here, so you can get a puller down in here. That's the way to do it, but don't ever pull or lever on these on this edge, because it will just come off and then you'll be very annoyed. So it looks like it's about a good size. I can pick up in here and drill and screw it on here with some spacers. Get it off enough, and then I've still got enough space behind the cover for the caliper and everything. So I think this is going to work. The only thing I'm worried about is, will it get enough inertia on here to stop it in time? Ideally I wanted to be on the motor, but I'm going to try it here first. If this doesn't work, then I'll go for the more difficult option on the motor. Okay, so decisions. The disc mounts easier on here, but I'm not going to get as much torque to stop it. Also, I don't have a lot of room around this pulley, so really not ideal to put it on this pulley. I've got a lot of room around this pulley, but I don't have a lot of real estate to actually screw into. If you look, you know, because I don't want to break into here because it'll start damaging belts, and I don't want to break into here because it just weakens the pulley. So what I'm going to make an adapter plate that can fit on here, and then this screw onto. So, and it's got to be strong because there's going to be a lot of torque put on this to pull this to a halt. So yeah, let me get this on the mill. I'll dial it up, and I'll put my I'm going to put 4 holes in, 4 screw holes, and find out what centers is going to be ideal, so that I don't break in either way. Well, I want to use some nice high tensile bolts as well. So I don't want to use any cheap soft bolts. They've got to have a good shear strength. Okay. Okay, so for cutting circles with a plasma cutter, I've made this or modified this device so that you can put it in there, dial up whatever diameter you want, and then you can just cut it in a nice circle like that. And I've worked this quite a few times, and it's always worked pretty well. Unfortunately, this is for bigger circles, and I couldn't get a clamp on to clamp the work down, so I just put a tic-tac weld and welded it to the bench. I grind that off afterwards. So I'm going to just make a 4-inch diameter disc, and then we use this as the hub adapter for that pulley. Pretty good. Well, I've got this bit of old swarf on the end here, the little wheel jammed on it, so I just got that little hiccup just there. Other than that, that's a nicely cut disc. So we can use that now for the hull. I get asked, is it okay to keep welding to your table? Yes it is, because you just grind it off. And the way welds work is, so if I've welded, it's only a tack weld, it's not a proper weld. If I've welded in that plane there, it's got lots of strength this way, pushing down, trying to pull up or twisting. It's got a lot of strength that way. But a weld like that has zero strength that way. And that's why when you're welding, you've got to make sure that you get a weld. It's got to be stable. The whole piece has got to be stable. You can't just have a weld there and just be able to hinge it off. So now we've taken it off. I've got a little bit of splatter here. I'll just get the grinder on there and grind that off. Not a problem at all. Doesn't mess with the bench. So here's the disc. There's the cut cleaner that I could have done with a saw. Nice and round. So now I've got to just drill the holes, mount it to the pulley, and then mount the brake disc to that. So it's just like an adapter plate, but it's got to be pretty strong because I'm going to be asking it to stop the lathe. Okay, so we're going to do some holes. So I've got that mounted on there, and that's good there. It's the same. So I've got it centered within half a thou all round, so that's going to be good enough to mount the disc on. So I think 4 holes. So that's a probably a metric shaft. No, it's not. 1 1/16. That's a strange size shaft. Okay, so probably want the centers at about, let's do it metric, 40 millimeters will give me there, because I don't want to break into the V here. So to do 4 holes on an XY would be pretty easy. 40 millimeters, I could just go 0Y plus 20X, and then plus 20Y, 0X, minus 20, 0. And so 4's easy, but I wanted to play with this. So we're going to be in metric. There. Center position is 0. Diameter is 40. Starting angle we're going to have as 0. Ending angle is, because it's only 4 holes, you don't go back to 360 because that would be 5 holes, is 270 degrees. Like that. Okay, number of holes, 4. So the first hole is 20 on this axis, that way. So we're going to start drilling. So all I've got to do is bring that to 0, and that tells me that I'm in the correct position for drilling the first hole. And the bed's moved a little bit the other way, so I'll 0 that. All right. down a little deeper. I'm going to drill all the holes first and then come back and put the threads in. I think that's going to be deep enough. Okay, that's going to be fine. So the next thing we do is hit hole number 2, and that is going to be 20 that way. And 20 this way. So you see, it would have been easy just to do this without the DRO, but it's nice to use your tools if you've got them.
Mm-hmm. Otherwise, what's the point in having them?
Exactly. Okay, it's ready for the next hole. Put a bit of ink lube on there. I've got the depth of the hole set. Got the depth of the hole set here, all ready to go. Anchor loops on. Perfect. Next hole. 20 this way. Do that way. Drilling cast iron is very nice, drills nicely. Next hole. Go that way. Perfect. Okay, let's put some threads in it. Wind that in. Just going to do it by hand. I don't want to break a tap in it. That's in. That's one done. Next hole. could have just changed the drill, the drill and the tap out at every hole, and I wouldn't have had to reposition it. If I was doing a lot of holes, I could have done it like that, but with only 4, I decided to do it like this. Undone the tap. That's right. Not going to be able to get in very deep on any of these, but fortunately it's a lateral load, not a pulling load. Next hole. I used to have my coolant running, and there was coolant everywhere, and it didn't necessarily bring the swarf up out very easily. But I've discovered this stuff, and it definitely does make cutting and things like this nice and easy. It's good for like small milling jobs, but if I was going to do anything really big milling, I'd still use the coolant just to flow everything off it. So that is that done. Okay, that's my 4 holes. So next thing, I've got to transpose that onto that adapter plate. So same again with the adapter plate, 0 it out, and central position 0, diameter is going to be the same as the last one. Starting angle 0, ending angle 270, number of holes 4. So what we're going to be doing now is just drilling the clearance holes for the screws that's going to screw into that other part, into the pulley. So we did those screws at 6mm. About there. Okay. that's the holes done. So I'm going to use these cap head screws because they're really tough. And that's going to drop in there like that. Now the distance of that is a fraction wider than the inner hole of the disc, so I could either make the inner hole of the disc a little bit bigger, or I can just spin a little bit down off of these, and I'm talking about 1/4 millimeter, something like that. So I think I'm going to just slim the heads down a little bit so that disc can then fit over the top. That will save me having to countersink these and use countersink screws, because these are a better screw. Okay, so now we're going to do the other hole. So we're going to bring that back to 0. Okay, so zeroed it off. Now this one, center position. Now the diameter of this is 68 millimeters, is the centers in that disc. Starting angle, we're going to have a 0, ending angle 270 again, because we're just going to have the 4 holes, number holes 4. So the first is 34 millimeters over there. There, okay. The tapping drill for an 8mm, because that's an 8mm hole in the disc, so we need to do an 8mm thread in here. Tapping drill is 6.8 millimeters, so I'll start it up. These are self-centering drills, so I don't need to use a center. They center themselves pretty nicely. Okay, this side, this is because this is a through and through hole, it's not a blind hole. I'm gonna power it. It's a little fast. Oh, I don't know, it's a little fast. Set down. Still a bit fast. There we go. And then reverse it out. Perfect. I didn't want to do that in a blind hole. That couldn't have ended well. Okay, next hole. And let's just do that again. On there and that on there. That on there. Might have to cut these down a bit, they're a bit long. down. I'm going to cut them down that much. Calipers here somewhere, I've lost them. Yeah, if we take 5mm off, that would be perfect. But I wanted to see how much I'm going to have to remove off the diameter. Yeah, not much at all. Okay, so I just need to take a bit of off the diameter of the bolt heads and 5mm off their length. Let's do that. Okay, so we've mounted the plate on and cut the screws down so they are done. These screws are now fit inside the centre hole, so we mount that now on there. So when I said, oh yeah, I'll just spin the heads of those bolts down, that assumed that I had a lathe that was working, but I don't because of this pulley. So we had to grind them down by hand, which was a bit of a nuisance, but we got it done. But it would have been a lot easier if I'd have had a lathe. Maybe I need 2 lathes, but I don't have the space.
Well, you could get a mini lathe.
Okay.
Smaller one. Just for little things.
Okay, so there it is. The disc is now mounted on the pulley. So let's put it back on the lathe and then work out how we're going to get the caliper to mount on the lathe as well. Get that other pulley back on that I took off. Now I've got to line this pulley up with this pulley. Let's just very important your pulleys line up, otherwise you'll just screw the belt up. What I'm doing, I'm eyeing down the edge of these two edges of this pulley and lining up with that edge there, and the same on the back here. So if I line those, run through there, I can see that these V's are now perfectly in line. I'm going to lock that in place. Find that Allen key. I think it's this one. Nope. Okay, now I'm going to turn it on. I'm going to see how true that pulley, that disc is. And that is spinning absolutely perfectly true. Excellent. So if I put the belts back on, so I know where the belts are, and I've got to mount that caliper, probably down here somewhere. I want to mount it somewhat with the mount of the motor. Otherwise, if I have to adjust the motor for the belts, the caliper will be out. Now that is a clean cut. I don't care what anyone says, that's a clean cut. Awesome. Okay, so that's the caliper mounted, so that piece I plasma cut, just bent and then drilled and tapped onto the foot of the lathe. And as you see, it mounts in there quite nicely. So just it would have helped if I'd have put the belts on first though. What do you reckon? Oh bugger. Okay, let's put the belts on. Well, quite a bit of this metal square tubing, rectangular tubing. It's from crates that I get delivered machinery in, and then once we unbox the machine, the metal crate is no longer required. So normally it would go in the trash, but it's really good stuff. I mean, this I've got inch by inch square. This is some inch, I think it's inch by inch and a half, and I've got some 2 inch by inch. It's very good stuff, and it has these end flanges, some of them, which are really strong. I always like to repurpose things like that. I don't like to throw things away. So this is going to be the foot switch. So this is going to mount on there, and this will screw to the wall of the foot of the lathe. Then the actuator, the hydraulic master cylinder will mount on here. This is 22 inches long. I want a half inch, or just under half inch of travel here, and I thought a 2 inch travel there. So it's about 4:1, just a little bit less. I don't want it to be more than half an inch at this end. So 22 inches long, a 5 inch pivoting point gives me just about what I want. I could put a stop here to stop me from over traveling it, and then on this end I'm going to have a bolt in the end of here in a slot on an upright, so that will hold it and stop it from wandering around. And then there'll be a micro switch or a plunger switch at this end, so the moment you hit the bar it'll trip the interlock on the motor and turn it off. That way the motor is electrically off before you start applying the brake. So next step is to weld all this up and mount the master cylinder on here and check it all works. So just checking my angle. So I need this to move 1/2 an inch at this end when it pivots. It's going to be from there. I need to make sure it's not going to bash on here or here. So I think if I have it 1/2 an inch off of there, and just have it 1/2 an inch up, that should be good enough. Yeah, I think that's about where I want it. So let's drill that. Come on. Right. Help if I was in the middle. There you go. I mean, it's exactly where it is not that important. Perfect. About there. On there. Let's go on about there. Yeah. Take that on there. You see that? That's not bad. Quite happy with that. Wait. Just take that. Okay, come down here. Let's do this. And we're going to come this side.
Where I can.
What do you see?
Where you do like that.
That's really good. Okay. Put that off a bit.
Now we just adjust.
And down. Okay, ready? Go.
3, 2, 1, go.
It's pretty good.
Yeah.
That's really good. Well, that's not coming off. Okay. You got enough protective clothing on?
Yeah,
Yeah, your mum would kill you if I burnt you.
that's true.
Now, this is the time to use the actual coolant. Let's see what I'm doing better. Okay. Was tempted to go in there with my finger and brush it away, but it's never a good idea. Okay, let's see how that looks.
Three,
There.
two, go. Oh, it's melting.
What?
It's melting.
That's right. Okay, come in this way. Helmet. Go.
You ready?
Yeah. Stop. That's okay. No problem.
We'll get near the spear bit.
Yeah, that's fine. You take that, dude. Stop. Stop. That's there. It's on. Okay, now do this side here. That's it. That's okay. Don't touch me there. That's perfect. That's really good. Excellent. Good. Okay, so we're nearly there. So that slides up and down, so it gives it limits either way. Pivoted here, and it pushes the master cylinder up there. So it should give us enough travel. So all I've got to do now is put the plunger switch on to kill the engine or the motor. Okay, so I've mounted the switch. That extra tension of the switch made that the spring loading from the master cylinder wasn't enough to hold it, so I had to add another spring on the end here, which now brings it up, makes the switch. So that's it. All I've got to do now is screw it into place, fill it with hydraulic fluid and bleed it out. Okay, so here we have the alleged drawing for this lathe. So you can see the drop down transformer for the control circuit, 220 volts in. Here's all the motor, single phase, 220 volts. So it's a capacitor shift motor or capacitor start motor. And here on the control circuit it is saying that it's 29 volts. Okay, so that sounds pretty good. So you hit the emergency stop, it trips out the relay, so when you let go of the emergency stop, it won't come back on accidentally. So that's where we need to break in. We need to break in this line here, so that when we hit the foot switch, it drops the control relay, turns it off, and then when you let go of the switch, it doesn't come back on. So that's where we need to go. So here we are. It is isolated completely unplugged, so we're good. Here's the emergency stop button. It's a latching button, but if you hit it and it's engaged, even if you unlatched it, it won't come back on. So this is the line we need to break, this line here. Now it gets its power from this transformer, which doesn't say 29 volts on it. It says 24 volts or 110. So what's coming out of here? And I measured it, and it's 130 volts we have on here. So this is giving out a little bit more than it says, and it's not running on the 24 volts. So this is supposedly a 110 volt latching relay, not a 29 volt one or 24 volt one. So that just makes that the wiring we put from here down to our foot switch now has to be okay for 130 volts, and the switch we use has got to be a mains rated switch as well, and we're going to have to run an earth to earth that foot switch. So very important that we check this. Otherwise it could have been a bit tricky. Okay, so there it is, mounted on there. So I'm going to start it up, and I'm just going to touch the, actually no, I'm going to hit the interlock to see if it'll interlock it already. So okay, so you can hear it's dropping the interlock out. So let's start it up and see how quick it stops. Wow. Oh, that's way better than I thought it was going to be. Try again. And that stops it within a turn or two. Oh, well, that worked out a lot better than I expected. This has been a problem I've had with this for years, not being able to stop it in time. Thread cutting is, do I manage to stop it in time, or do I disengage the half nut? You know, what do I do? But now I can just stop it, back it, reverse it out. A lot easier. I can get some nice thread cutting done. Also, I can stop that machine instantly if I need to with my foot. I don't have to try and reach across and hit a button and then wait for it to wind down. So I hope you have found this helpful. I hope this may solve a problem you've got. So please subscribe and hit the like button, and I'll catch you all in the next one. Thanks a lot.